Hello my friends and welcome back to the You Can Do TV channel. Constructing a log cabin is a meticulous process that combines traditional craftsmanship with modern techniques. The build begins with square beams which are carefully milled into uniform logs to ensure precise fit and stability. Each log is stacked on a trailer frame, forming the structural shell of the cabin. Once the frame is assembled, the logs are sanded to smooth out surfaces and remove imperfections, preparing them for finishing. The next step involves installing the roof, which protects the cabin from weather and completes the exterior structure. Throughout the process, attention is paid to alignment, joinery, and structural integrity, ensuring a safe and durable cabin. Finally, the entire cabin is painted or treated with a protective exterior finish, ensuring long-term durability and weather resistance while giving the cabin a polished, visually appealing appearance. This workflow demonstrates how log cabins can be efficiently constructed while preserving the natural character and warmth of the timber, resulting in a cozy, long-lasting structure suitable for a variety of settings. In wooden pallet production, industrial wood planers ensure every board is perfectly smooth and dimensionally precise before assembly. With dual planing heads, these machines flatten both the top and bottom surfaces in a single pass, guaranteeing uniform quality and efficiency. After planing, the boards are assembled into robust pallet frames using pneumatic nail guns. This precise fastening method creates strong, stable pallets, capable of handling heavy loads with ease. Every step, from planing to assembly, is carefully controlled to combine mechanical precision with craftsmanship. The result is high-quality wooden pallets produced efficiently and consistently, ready for transport and storage. This process demonstrates how advanced machinery and skilled assembly work together to create durable, reliable pallets, highlighting the technical sophistication behind everyday industrial wood products. The fabrication of wooden foudres is a highly specialized process that combines traditional cooperage craftsmanship with precise technical control. It begins with a careful selection of timber, typically oak, chosen for its mechanical strength, dimensional stability, and suitability for long-term contact with wine or spirits. Logs are split along the grain and sawn into staves, which are then naturally air-dried to reduce internal stresses and ensure long-term durability. Once properly seasoned, the staves are machined, tapered, and calibrated to achieve uniform thickness and accurate curvature. The staves are then assembled vertically around a circular template. This initial assembly is performed without adhesives, relying instead on temporary steel hoops to apply compressive force, allowing the staves to lock together through precise geometry. The partially assembled foudre undergoes a controlled heating process, which softens the wood fibers and enables gradual bending while improving natural sealing properties. After the desired shape is achieved, the top and bottom heads are fitted, and permanent steel hoops are installed to maintain structural integrity. Internal surfaces may be lightly toasted depending on the intended application. The finished foudre is then filled with water for leak testing, inspected for tightness, and adjusted if necessary. This meticulous process produces large-capacity wooden vessels with excellent strength, stability, and long-term performance for aging and storage applications. The Koma Tai Sofa 2024, designed and crafted by Shigeki Matsuoka, represents a precise integration of woodworking technique, material engineering, and sculptural furniture design. The sofa's defining form is created through a highly controlled process in which solid wood is transformed into a continuous, flowing structure while maintaining structural integrity and long-term stability. The production process begins with the careful selection of solid timber, chosen for consistent grain orientation, density, and moisture content. The wood is first cut into multiple narrow strips, each dimensioned to allow controlled curvature without inducing excessive internal stress. These strips are then machined into curved segments with interlocking joints, ensuring accurate alignment during assembly. The joint geometry is designed to maximize bonding surface area while preserving the natural fiber continuity of the wood. High-strength structural adhesives are applied during lamination, and the curved elements are clamped under controlled pressure to achieve a unified form. This lamination technique allows complex three-dimensional curves to be realized using relatively thin wooden components, reducing the risk of cracking or deformation compared to bending thick solid sections. Once the adhesive has fully cured, the assembled structure behaves as a single composite element. Following assembly, the sofa frame undergoes precision cutting, grinding, and surface shaping to refine the final curvature. Excess material is removed to achieve the smooth, continuous lines that characterize the Koma design. CNC-assisted milling and hand-finishing techniques are combined to ensure dimensional accuracy while preserving tactile quality. The surfaces are progressively sanded to achieve uniform transitions between joints, making the laminated structure visually seamless. The final finishing stage focuses on surface protection and aesthetic expression. Natural oils or clear coatings are applied to enhance grain visibility while protecting the wood from wear and environmental variation. Through this meticulous process, the Koma Tai sofa embodies a balance of traditional craftsmanship and modern fabrication, where segmented curved elements are transformed into a cohesive, structurally sound, and visually fluid furniture form. The production of FRP fishing vessel molds at Heiwan Marine Shipyard is a highly precise and technical process, combining skilled craftsmanship with advanced composite techniques. The workflow begins with a wooden plug, meticulously shaped to replicate the exact contours and hydrodynamic design of the intended vessel. Craftsmen carefully carve, sand, and refine the plug, ensuring every curve and surface is smooth and accurate, as this plug will determine the quality of the final mold. Once the plug is complete, it is coated with release agents to prevent adhesion, and layers of gel coat and fiberglass are applied to form the female FRP mold. Each layer of fiberglass is saturated with resin and compacted using rollers or vacuum methods, eliminating air pockets and ensuring uniform thickness. Venting and reinforcement plates are incorporated to strengthen the mold and maintain its shape during production. After curing, the mold is carefully demolded, trimmed, and inspected, with any imperfections corrected. Openings for hatches, fittings, and other features are added. The final FRP mold is a durable production tool, capable of producing multiple identical hulls efficiently. This process, from wooden plug to reinforced FRP mold, ensures accuracy, durability, and consistent high-quality output for fishing vessel construction. OCCA Chair Factory is a modern manufacturing facility specializing in the design and production of high-quality chairs for residential, commercial, and office environments. With a strong focus on craftsmanship, technology, and sustainability, OCCA combines traditional manufacturing values with advanced industrial processes to deliver products that meet international standards. The production process begins with careful material selection. Premium wood, high-grade metal, durable plastics, and certified upholstery materials are sourced from trusted suppliers. Each material is inspected to ensure strength, consistency, and long-term durability before entering the production line. This strict quality control at the input stage forms the foundation of every OCCA chair. Manufacturing is carried out using a combination of CNC machinery and skilled manual workmanship. Automated cutting, bending, and welding systems guarantee precision and efficiency, while experienced technicians handle assembly, sanding, and finishing to ensure comfort and aesthetic excellence. Ergonomic principles are applied throughout the design and production stages, allowing OCCA chairs to provide optimal support and usability. Surface treatment and finishing are key strengths of the factory. Chairs undergo multiple stages of coating, painting, or upholstery installation depending on the model. Environmentally friendly paints and finishes are used to reduce emissions while maintaining a refined appearance and high resistance to wear. Upholstered products are carefully stitched and padded to achieve both comfort and durability. Quality assurance is integrated into every step of production. Each finished chair is tested for stability, load capacity, and surface quality before packaging. OCCA Chair Factory also emphasizes sustainable manufacturing by minimizing waste, optimizing energy use, and improving production efficiency. Through continuous innovation, skilled labor, and a commitment to excellence, OCCA Chair Factory delivers reliable, stylish, and long-lasting seating solutions to customers around the world. Brickwood is an innovative construction system based on precision-engineered wooden boards designed to function as interlocking structural bricks. These modular wood elements are manufactured with tight tolerances, allowing them to lock together mechanically to form load-bearing walls without the use of glue, nails, or screws. Construction follows a dry assembly method similar to a large-scale puzzle, enabling a small house or cabin to be erected in a single day. The solid wood bricks provide effective thermal and acoustic insulation, improving energy efficiency and interior comfort. Because the system relies on mechanical interlocking rather than permanent fasteners, structures can be easily disassembled, modified, or relocated. Brickwood combines structural simplicity, material efficiency, and rapid installation into a sustainable wooden building solution. Sankria Group operates a highly integrated furniture manufacturing facility designed to control every technical stage of production, from raw material processing to finished upholstered products. The manufacturing workflow begins with the selection and conditioning of solid wood and engineered wood materials, which are dried and stabilized to ensure dimensional accuracy and long-term structural performance. Once prepared, materials enter the machining phase, where precision and repeatability are critical. Advanced CNC cutting systems and automated panel processing lines are used to cut, drill, and profile components with tight tolerances. In parallel, automatic lathes and CNC turning machines are employed to manufacture chair legs and other cylindrical or curved structural parts. These machines ensure consistent geometry, smooth surface quality, and high-volume output while minimizing material waste. Complex shapes and repeatable designs are produced with exact alignment to downstream assembly requirements. For load-bearing and curved components, Sancrea utilizes laminated wood pressing systems. Layers of wood are bonded with industrial adhesives and pressed under controlled pressure to form strong, stable elements such as frames, legs, and structural panels. This process enhances mechanical strength, reduces deformation, and allows for refined design flexibility. After machining and pressing, components move to assembly lines where frames are joined using screws, fittings, and reinforced joints. Upholstery operations follow, combining technical precision with skilled craftsmanship. Fabric and leather materials are cut, sewn, and mounted onto frames using dedicated sewing machines and pneumatic tools. Foam padding and ergonomic layers are installed to meet comfort and durability standards. The final stage includes surface finishing, quality inspection, and packaging. Each product is checked for structural integrity, dimensional accuracy, upholstery consistency, and visual quality. Through the integration of automated machinery, engineered wood processes, and controlled upholstery production, Sancrea Group delivers furniture solutions that meet demanding technical, aesthetic, and performance requirements for international hospitality and contract markets. Japanese timber architecture is deeply rooted in a long-standing cultural principle of harmony between the built environment and nature, which today is translated into technically advanced, sustainable construction systems. Modern wooden buildings are developed within a forest grand cycle, where trees are planted, harvested, utilized, and regenerated to ensure continuous material supply and economic circulation. Engineered wood products such as CLT, cross-laminated timber, and structural glulam enable mid- and high-rise timber construction with predictable strength, dimensional stability, and fire resistance performance. Hybrid timber systems combine large section glulam members, truss structures, and fire-rated composite assemblies to achieve long spans and multi-story loads. Material traceability ensures that timber used in buildings can be linked directly to managed forests, reinforcing responsible forestry and regional industry. From a building science perspective, wood contributes to improved indoor comfort through thermal moderation, acoustic absorption, and psychological calming effects. As building codes evolve, timber construction is positioned as a high-performance, renewable structural solution supporting low-carbon urban development and next-generation architectural innovation. Besa Home approaches design and production with a strong emphasis on technical precision, material performance, and long-term durability. Each project is managed through a structured workflow from concept development to final installation, where dimensional accuracy, load-bearing requirements, joint detailing, and surface performance are carefully evaluated and integrated into the design. Advanced manufacturing infrastructure plays a central role in this process. CNC-controlled cutting, precision drilling, and engineered joining systems ensure high component accuracy and consistent assembly quality. Timber-based materials are processed under controlled moisture conditions to minimize deformation and ensure structural stability. Composite panels, high-density MDF, and natural veneers are selected based on their resistance to mechanical stress, temperature variation, and extended daily use. Multi-layer surface coatings and protective finishes enhance abrasion resistance while reducing long-term maintenance requirements. Home prioritizes modular construction and intelligent connection systems to optimize installation efficiency and adaptability. This approach allows customized configurations without compromising structural integrity or production efficiency. Storage units, movable panels, and multifunctional furniture systems are engineered with careful consideration of static balance, ergonomics, and user safety. In conclusion, Home combines modern manufacturing technology with skilled craftsmanship to deliver high-performance interior solutions. Through rigorous technical control, advanced material selection, and detailed engineering, each product achieves a balance between functional reliability, architectural clarity, and enduring design value. Guppy Systems delivers a purpose-built material handling solution engineered to eliminate the primary bottleneck in cabinet finishing operations. Developed by industry professionals with decades of hands-on experience, the system addresses the inherent inefficiencies of traditional flat spraying, where excessive handling, long wait times, and surface contamination significantly limit productivity. At its core, Guppy Systems integrates mobile rails, fixed spray booth rails, and pivoting carriers into a continuous flow finishing process. Mobile rails transport up to 20 components simultaneously and connect seamlessly to the spray booth rail, enabling smooth transitions without manual lifting. Components are suspended on pivot carriers that index in 90-degree increments, allowing all sides to be coated in a single pass. This design eliminates repeated flipping, reduces idle time, and allows the finisher to work continuously without setting down the spray gun. As a result, throughput becomes limited only by spray application speed rather than material handling. The system is engineered for flexibility and scalability. Specialized hangers securely hold doors, drawer fronts, face frames, and shelves using concealed attachment points that leave no visible marks after installation. Vertical spraying improves finish quality while reducing defects caused by dust, debris, and overspray. Ergonomics are also enhanced, placing the finisher in an upright working position and reducing physical strain. Configurable to any shop layout and expandable over time, Guppy Systems delivers automation-level efficiency while preserving the skill, control, and craftsmanship of the professional finisher. The construction of a wooden house follows a structured technical sequence designed to ensure load-bearing performance, dimensional stability, and long-term durability. The process begins with the preparation of the reinforced concrete foundation system, where columns and footings are cast to precise elevations and equipped with anchor bolts or steel connectors. Once cured, primary timber beams are accurately positioned on top of the concrete columns, forming the base of the wooden structure and ensuring effective load transfer from the superstructure to the foundation. At key structural interfaces, dovetail mortise joints are carefully machined into the timber members. These joints provide strong mechanical interlocking, reducing the risk of horizontal movement and improving overall structural stiffness. In addition to traditional joinery, modern fasteners such as structural screws and metal connectors are integrated to meet contemporary engineering requirements. All timber components are treated with protective preservative coatings, which enhance resistance to moisture penetration, fungal decay, and insect attack. Following the installation of the primary frame, wooden panels and framing elements are assembled using high-strength screws to achieve tight, controlled connections. This approach allows precise alignment while accommodating natural wood movement over time. A steel sheet layer is then installed as an intermediate reinforcing and separation layer. This sheet improves load distribution, adds stiffness to the assembly, and protects the timber structure beneath from localized stress concentrations. Next, additional wooden panels are installed above the steel layer, completing the floor or wall assemblies. During this stage, thermal insulation foam boards are inserted between structural members and panel layers. The insulation significantly improves thermal resistance, reduces heat transfer, and contributes to acoustic dampening within the building envelope. This layered system also enhances energy efficiency and indoor comfort. The same construction methodology is applied progressively to walls and roof systems, ensuring continuity of structure and insulation throughout the building. Each stage is inspected for alignment, fastening integrity, and material protection. Through this systematic process, the wooden house achieves a high level of structural integrity, thermal performance, and durability, resulting in a sustainable and technically robust residential solution. Dorsey operates a technically sophisticated door manufacturing facility covering over 2 hectares, with more than 3,000 square meters of production halls and a workforce of nearly 100 skilled professionals. The factory integrates traditional woodworking expertise with modern automated machinery, CNC technology, and advanced finishing systems, ensuring high-quality interior and exterior doors with precise dimensions and superior surface finishes. The production process begins in the sawmill and drying sections, where raw timber is carefully selected, cut, and sorted based on species, quality, and intended application. Kiln drying is applied to achieve precise moisture content, preventing warping or deformation and ensuring stability for downstream machining and assembly. Moisture levels are continuously monitored throughout the process, and timber is conditioned for structural strength and dimensional accuracy. Once dried, timber enters the machining phase. Dorsey operates 2 advanced CNC centers capable of performing a wide range of operations, including cutting, milling, routing, grooving, and shaping panels and frames. Complex profiles, decorative patterns, mortises for joinery, and door edge treatments are executed with repeatable accuracy. The use of CNC technology minimizes material waste, reduces manual handling, and ensures consistency across batches. After machining, components are sanded and undergo surface preparation, including priming and painting or varnishing in dedicated lacquer lines. Rollers, spray booths, and automated paint systems are used to ensure uniform coating, while UV or heat-assisted curing accelerates drying without compromising surface integrity. Edge banding and decorative moldings are applied using precision jigs and automated tools, while certain high-detail elements are manually processed to meet specific design requirements. The assembly phase brings together stiles, rails, panels, and fittings into fully finished door units. Wooden dowels, screws, and adhesive systems are used to reinforce joints, while hinges, locks, and handles are integrated according to customer specifications. Each door undergoes rigorous quality inspection, including dimensional verification, surface finish assessment, and mechanical testing to ensure reliability and durability. Finally, completed doors are stored in the finished goods warehouse, packaged for protection during transport, and dispatched efficiently to customers. The entire production workflow at Dorsey emphasizes precision, technical control, and optimization of material and labor resources. Heavy timber near-site fabrication work refers to the on-site or near-site processing and assembly of large section timber structural components that have been pre-machined in the factory. Columns, beams, and trusses are assembled using precision-cut mortise and tenon joints, dovetail connections, and steel connectors to ensure accurate alignment and structural continuity. This method improves transportation efficiency, reduces on-site tolerances, and enables rapid crane-assisted erection. Key quality controls include moisture management, joint fit verification, and controlled fastening torque, ensuring structural integrity, construction safety, and consistent performance of heavy timber building systems. Custom curved wood railings for spiral staircases can be manufactured and delivered efficiently using bendy wood through a simplified three-step bending and transport process. This engineered wood product is designed for controlled flexibility, allowing handrails to be shaped without complex or permanent bending molds. In the first step, the straight, bendy wood handrail is bent horizontally around a low-cost flat mold. This mold defines the required radius and curvature while maintaining uniform cross-sectional geometry. Because the bending occurs in a flat plane, tooling costs are significantly reduced compared to traditional three-dimensional molds. Once the handrail is fixed in position, it is allowed to stabilize, ensuring the curve is retained without internal stress buildup. The second step focuses on logistics. Instead of shipping a fully formed spiral handrail, the curved element is secured onto a compact transport mold. This allows long, curved handrails to be packaged into manageable dimensions of approximately 2 × 2 meters. The reduced package size minimizes handling complexity, lowers shipping costs, and simplifies on-site storage. In the final step, the handrail is bent vertically on site and installed directly onto the spiral staircase. The pre-curved geometry allows the handrail to follow the stair's helical profile without additional shaping or specialized equipment. This method eliminates the need for on-site bending molds, reduces installation time, and ensures consistent curvature. Overall, Bendywood provides a practical, cost-effective solution for producing, transporting, and installing custom curved wood railings with high precision and efficiency. The Bison 37-ton log splitter is Sweden's powerhouse for professional firewood production, engineered to tackle even the toughest logs with unmatched strength and speed. In the video, the machine effortlessly splits extremely dense timber, including a test where a log is placed against the grain, completely crushed under its immense force. Equipped with a reinforced hydraulic system and a durable frame, the Bison 37-ton delivers long-lasting performance, high throughput, and consistent results under continuous operation. Its design allows operators to process large volumes of wood efficiently, reducing labor and time. Ideal for commercial wood processing or anyone demanding a log splitter that can handle extreme conditions, this machine combines precision engineering, reliability, and raw power. The Bison 37-ton exemplifies modern log-splitting technology, providing both productivity and durability for demanding forestry and firewood applications. New Life furniture manufacturer utilizes advanced woodworking machinery to ensure precision, consistency, and high-quality output in furniture production. Core equipment includes the Woodmaster WM618 6-spindle 4-side planer, which delivers accurate profiling, smooth surface finishing, and stable dimensional control for solid wood components. For panel processing, the factory operates the Holztech Tektra 328 FCNC panel saw, enabling high-precision cutting, optimized nesting, and efficient material utilization. Following primary machining, components undergo multi-stage sanding, drilling, and CNC-assisted shaping to achieve tight tolerances and clean joint interfaces. These processes support accurate assembly and long-term structural performance. Through controlled machining, detailed finishing, and systematic fabrication workflows, raw wood and panels are transformed into refined interior furniture products that meet international quality standards and aesthetic requirements. The wooden packaging production process for fruit and vegetables at Smiljanek DOO in Vukovar is organized to ensure structural reliability, dimensional accuracy, and logistical efficiency for agricultural supply chains. The primary objective is to manufacture wooden crates, trays, and boxes that provide adequate load-bearing capacity, ventilation, and safe handling throughout transport and storage. The process begins with raw material selection and preparation. Timber is chosen based on mechanical strength, low weight, and suitability for short and medium-term packaging use. Moisture content is controlled to reduce the risk of warping, cracking, or joint failure. Logs and lumber are sawn into boards and slats according to predefined dimensions for side panels, bases, and structural frames. This is followed by cutting and machining operations. Wood components are cross-cut and ripped to length, then planed to achieve uniform thickness and smooth surfaces. Edges are processed to remove splinters and improve handling safety. Where required, simple notches or grooves are machined to improve alignment and joint stability during assembly. During the assembly stage, individual components are joined using industrial nails or staples to form complete packaging units. The structural layout is optimized for stacking strength while maintaining sufficient airflow to preserve fresh produce quality. Consistency between units is maintained through standardized assembly sequences. The final phase involves quality inspection and finishing. Each unit is checked for dimensional conformity, joint integrity, and overall rigidity. Minor surface corrections are performed before the finished wooden packaging is stacked, bundled, and prepared for delivery. This controlled production workflow ensures dependable, cost-effective wooden packaging tailored to fruit and vegetable transport requirements. Takanaka Corporation has introduced the Rule Bench at JR Osaka Loop Line's Bentencho Station, created using large-scale metal 3D printing. Former railway rails are upcycled into a sculptural public bench, showcasing advanced additive manufacturing and a new circular metal resource system that transforms industrial scrap into functional urban furniture. Ravok's bathroom furniture production represents a refined balance between industrial precision and craftsmanship, delivering durable, high-quality solutions for modern bathroom environments. The graphic furniture line is developed in close collaboration with Ravok's designers and engineers and manufactured entirely in the company's own production facility, ensuring full control over quality at every stage. Deeply impregnated chipboard and MDF panels form the structural foundation, providing excellent moisture resistance and long-term dimensional stability. Manufacturing begins with large-format panels that are digitally optimized and cut into components using high-precision saws. Computer-controlled cutting achieves accuracy within 1/10 of a millimeter while minimizing material waste. Each part then undergoes drilling and milling to create openings, grooves, and precise connection points, all continuously monitored for consistency. Edge treatment and surface preparation are carried out using automated systems. Straight edges receive machine-applied edge bands, while complex profiles are coated through roller painting, followed by UV curing for fast and uniform hardening. Shaped front doors are produced separately by laminating multiple layers, pressing them into form and completing them through detailed milling, filling, and painting. Surface refinement combines machine sanding with skilled manual finishing, using multiple abrasive grades to achieve a flawless base. Painting is applied in controlled layers with timed curing intervals, followed by final polishing with felt discs to create a smooth, even sheen. In the final assembly stage, hardware components are installed, units are fully assembled, inspected, cleaned, branded, and securely packaged, ready for delivery as complete, premium bathroom furniture solutions. The multifunctional wood CNC lathe machine is an advanced solution designed for high-precision and high-efficiency wood-turning applications. This automatic CNC turning system is capable of producing a wide range of wooden components, including table legs, chair legs, stair balusters, columns, and decorative profiles. Equipped with CNC control, the machine ensures consistent dimensional accuracy, repeatability, and smooth surface finishes across batch and mass production. The system supports complex turning operations, such as straight turning, tapering, grooving, threading, and carving within a single setup. Automated feeding and tool control significantly reduce manual handling, increasing productivity while lowering labor dependency. High-speed spindles and rigid machine frames provide stable cutting performance, even when processing hardwood materials. With programmable parameters and flexible tooling options, the Wood CNC lathe machine delivers reliable performance, reduced waste, and scalable production for modern furniture and woodworking manufacturing environments. Modulux Homes operates a factory-based modular housing production process that emphasizes precision, efficiency, and on-site assembly simplicity. All structural elements are manufactured under controlled conditions in the factory, including wood and light-gauge steel frames, panel systems, insulation, and interior finishes before being transported to the construction site. The process begins with digital design and optimization, where building modules are defined by design parameters and production data. Structural components and panelized systems are then fabricated in dedicated production lines, achieving optimal throughput with minimal waste. Wood frames are treated to meet architectural performance standards, while steel frames are produced using fully automated systems to achieve precise geometry. Panels and structural elements are assembled at the factory into discrete volumetric modules or panel kits ready for installation. These modules are then transported to the site using standard freight logistics, greatly simplifying field installation. On site, modules are positioned on prepared foundations and assembled rapidly, often within days rather than months. Final connections, sealing, and site-level finishing complete the structure, delivering a complete residence that minimizes on-site labor and maximizes build quality. Koskisen Sawmill operates an integrated, technology-driven production process focused on the precision conversion of finished spruce and pine into structural and processed timber products. Selected logs are sawn using optimized cutting patterns to maximize yield, followed by controlled kiln drying to achieve specified moisture content. Timber is then strength-graded and machined on high-accuracy planing lines to ensure tight dimensional tolerances and consistent surface quality. The facility produces standard construction timber, planed goods, primed and painted panels, as well as customized cut-to-size components and special lengths for joinery applications. Continuous quality control is applied at each stage, including moisture monitoring, profiling accuracy, and surface treatment performance, ensuring predictable mechanical properties, compatibility with downstream manufacturing, and long-term durability in structural and industrial use. The process of assembling a traditional wooden lattice door begins by selecting and cutting joinery pieces, carefully examining the wood grain for strength and aesthetics. Mortises are carved into the frame, and tenons are chamfered for precise fitting. Glue is applied to connect each piece, aligning the upper rails and shaping the door. Vertical stiles are assembled to tighten the structure, and the craftsmen synchronize their work for the final fitting. Handles are installed, and finishing touches applied, completing the lattice door. The workshop combines technical precision with skilled handcraft, ensuring both durability and refined beauty. The wood recycling process begins with sorting and inspecting non-hazardous waste timber to remove contaminants like nails or screws. Logs and panels are shredded and ground into uniform sizes, then dried or treated depending on the intended use. For panel board production, fibers are blended with binders and pressed under heat and pressure, while biomass fuel and animal bedding are screened and packaged. Throughout the workflow, quality control monitors moisture, particle size, and cleanliness. Advanced machinery handles all stages efficiently, from shredding and drying to pressing and finishing, producing consistent, high-performance recycled wood products ready for use. The Valuetherm building panel manufacturing process begins with precise digital design, transforming architectural plans into high-performance prefabricated panels ready for construction. Computer-aided design communicates exact specifications to the factory, ensuring every panel meets stringent structural and thermal standards. Large timber elements are cut and optimized at the saw framing station, then lifting straps are attached for safe handling. Structural sheathing is glued and nailed using a computer-controlled nailing bridge, ensuring uniform fastening. Panels are turned over, and vent and injection holes are drilled according to the program design, with digital displays confirming program numbers. Panels are stacked and held firmly by a press, and insulating material is injected into each panel void. After injection, panels are turned over again for installation of breather membranes, followed by sealing of window openings. This workflow integrates precision engineering, automation, and quality control, allowing consistent production of structurally strong, well-insulated panels. The process emphasizes repeatability, high-quality assembly, and minimal material waste, making it a technically robust method for prefabricated panel production. Pinewood flooring is a natural building material commonly used in residential and interior applications due to its low density, ease of machining, and cost efficiency. Pinewood flooring is a lightweight natural flooring system valued for its workability and cost efficiency. Installation begins with floor-level adjustment to achieve the required elevation and surface flatness, typically using battens or adjustable supports. Tongue-and-groove pine boards are then installed with concealed fasteners and perimeter expansion gaps to ensure dimensional stability and long-term structural performance. Achieving a durable and visually striking roof begins with expert installation of Marley cedar shingles. The process starts on a 45-degree pitched roof with 25 by 38 mm fully graded JB red battens and a vapor-permeable membrane. Batten placement follows the gauge plus half thickness, 137 mm from the fascia, while shingles are fixed at a 125 mm gauge, with 25 mm overhang at the verge and 38 mm at the eaves or gutter line. A double course at the eaves is laid in a broken bond pattern. Shingles are fastened with 31 by 1.8 mm stainless steel nails or PA's load gun staples, 19 mm from the edge, and 38 mm from the course above. Straight alignment, 5 mm spacing, and broken bond patterns are maintained using guides or chalk lines. Shingles are cut at the ridge to keep the gauge, and pre-formed ridge units are installed from both verges, meeting centrally in a diamond pattern, ensuring a durable, efficient, and aesthetically flawless roof. Raising Modvion's first wooden wind turbine tower highlights a carefully engineered process centered on construction, transportation, and on-site installation. The tower is manufactured as prefabricated laminated timber modules, produced under controlled conditions to ensure dimensional accuracy and structural performance. Each module is designed to fit standard transport constraints, allowing the sections to be moved efficiently by road and sea to the installation site on Bjorko Island. On site, the modules are lifted sequentially using cranes and assembled vertically, forming a stable 30-meter tower. This prototype validates modular erection methods that will later be adapted for towers exceeding 100 meters in height. Modvion is redefining wind power infrastructure by accelerating the transition to renewable energy through the use of renewable materials. At the core of this approach is engineered wood, a bio-based material that combines exceptional strength with a low carbon footprint. By layering thin wood veneers into curved, tubular structures, Modvion creates towers that perform like natural carbon fiber, lightweight, rigid, and capable of reaching heights of 150 to 200 meters. The curved geometry of the wooden tower delivers outstanding structural efficiency, while the modular design solves one of the wind industry's biggest challenges: logistics. Instead of transporting massive steel or concrete cylinders, Modvion's towers are shipped in sections, making access to remote sites far more practical. Sourced from sustainably managed forests, the material regenerates naturally and stores carbon throughout its life cycle. Through innovative wood construction, Modvion demonstrates how large-scale infrastructure can support climate goals while transforming the future of wind energy.